let's say that I want to create a sphere, and I'll create once again, as usual, a PLT surface with a lot of particles on it, 100,000 particles. And instead of creating a light, I'm going to create a locator, and I'll just move it somewhere on the side. I'll pretend that this guy is actually a point light. I'll add a magma to my particles, and all I want to do is a simple lambda shader, so it will be the cosine of the angle with the normal, and that's all that I want. So let's say we want to set the color to we'll be blending two colors, so I'll say again a blend. They right now have 0 and 1, so it will be black and white. That's good enough. Into the blend, we'll be using the vector dot product. The one input will be the normal, and the other input should be the vector connecting the position. The position should be in world space, though, because this position is also in world space. So we'll convert this one to world, and then we'll subtract from the position of this point. So I'll swap the inputs here in order for the vector to be pointing in that direction. I'll reorder the whole flow, and then I'll say here in the subtraction, what I need is once again one of those property query operators, and I'll need the location of, I disconnected it, I think, but okay, this is the input. Let me see. I'll swap this one, I'll put this one here, and then I'll go here, and what I need is the locator. So, do I have it? Pretty much. The only thing that's missing is the normalization here, because dot product requires normalized vectors. So I'll go and say vector out vn, that creates a vector normalize. And now I have my shading, and because my sphere that I have created doesn't have enough segments, I can either go and get the smoothed normal, which will take me a while. I'd rather increase the resolution, and now I get my illumination. Of course, you can do func shading, calculate the reflection vector, and all the things that you would like to do. But I'm going to switch to another scene that shows the same and a little bit more. You have to keep in mind that when you're using Magma to create those effects, you're kind of creating surface shaders, and you cannot do the volumetric shading, really. So if you needed actual shadow casting and so on, you have to deal with it also. And in this example, as you can see, I have a scene where I have a sphere sitting on a plane. Both the plane and the sphere have exactly the same code that the same flow that I just created for my lambda shading. But this shadow here at the bottom is actually a ray trace shadow by checking each of the particles on the plane against the sphere if it's blocking the light from the light or not. The ray to the light, if it's hitting the surface or not. So if I go to my plane and say, show me this modifier, you're going to see that in addition to what I did before with the calculations, I also have an intersect ray here, and that intersect ray says, is the intersection valid or not? If it's valid, that means I hit the sphere before reaching the light, and I'll use the shadow color. Otherwise, use the shading color that I produced. And I'm outputting it as emission and rendering with self-illuminated particles without any lights in the scene, and that's what it produces. So you can write your own renderer with Magma if you want, do your own custom shading. In fact, yesterday, during the presentation, we got, after the presentation, we had a Q&A session, and one of the questions that were asked was, is it possible to do environment reflection maps? And that feature is actually available inside of the Max version of Krakatoa, and you can do it there, but you actually cannot currently check a checkbox somewhere in the renderer and say, I want to do reflection maps with some environment map, like spherical reflection maps. So this is the result of my tests. After the presentation yesterday, I sat down, I took an HDRI map as a reflection, and I wrote a Magma flow that basically takes the that reflection map, actually takes the vector from the camera to the surface, takes the reflection of that based on the normal, and then generates the texture coordinates for the bunny in this case, and then looks up the texel from the environment map as a spherical reflection map, and that gives you the result without actually having it as a feature of Krakatoa. We have added it on the wish list, so we'll get a checkbox in the future to do reflection maps, but right now you can actually simulate it with Magma. The flow looks a little bit intimidating. Here it is. This is the flow. I'll zoom a little bit out. The first part says, okay, this is the position of my camera. I had to take the explicit camera position and calculate a vector to the position of the particle, and then calculate based on the normal the reflection vector. And that reflection vector, after that, goes down into the bottom portion. And the bottom portion is calculating the UV coordinates that go as texture coordinate. And on top of that, I have a regular texture that uses that texture code channel that we generated. And basically, the reflection that I'm using is a large HDRI image, so the preview doesn't really sample it well. But I could potentially go and change that map to anything else. I used some of the 3ds Max HDRI environments that were coming with it because I know where they are. And yeah, that's how it was done. I'll explain it more on our website as a written tutorial, or probably a video. I think written tutorial will work better, so I can follow what exactly had to be done.